if they're here?
Should be fine now.
Cool, we got them.
Oh, that's not working. I'm completely doing it off of my data right now. I could chuck it all down.
Okay. Cool.
One moment. This is it.
Okay, everyone. I'd just like to start by saying congratulations. You've completely finished now. You've presented everything, and you've all done some incredible work. So really, just clap yourselves and pat yourselves on the back. And we'd just like to say, like, I walked around and saw some things, and even like the very small segment I saw, everything was awesome. So really, you've done a really great job, and just thank you for coming, and thank you, and I really hope you had a great time. So yeah, I'll just start by introducing the judges. We've got 6 awesome judges here, and yeah, I'll just let them introduce themselves and say a bit about what they do, and yeah, I hope you enjoy. Thank you.
Hi everyone, thank you for being here. I'm Cecilia Masker, I'm a professor of mobile systems. Yeah, I need it lower, that's right. I'm a professor of mobile systems in the computer laboratory. I'm interested in mobile, sensing, I've seen some cool demos of that, and behavior modeling and behavior studying and analytics.
Hello, my name is William Tunstall-Feddo. I founded a company in Cambridge called True Knowledge that changed its name to Evie and then got acquired by Amazon. So it's the origin of the Amazon Development Center. We do really cool stuff with natural language and with speech, automatically answering questions. We power Alexa, which is Amazon's equivalent of Siri, and we work with all sorts of very cool technology devices that you can talk to, like Amazon Echo and other things, other very cool things. We're based here in Cambridge. We've got a big development centre here.
Hi, I'm Rob Whitehead. I'm co-founder and CTO of Improbable, which is a distributed simulation company housed in central London. Previously, I was actually at a computer lab doing my tripos undergrad. I actually met some of these people. But yeah, Improbable doing some amazing work in like sort of taking things like commodity game engines, commodity simulation technology, and like being able to orchestrate tens of thousands of instances of these things on cloud hardware. Big simulations, millions of entities, super cool.
Hi folks, John from GitHub. I'm the education liaison. I work on all kinds of educational offerings for GitHub. You might be familiar with the Student Developer Pack. It gives you free private repos on GitHub and a bunch of other developer tools. I guess last thing I'd like to say is that if you're organizing a hackathon in the UK, come and find me. I'd love to talk to you about it.
Hello, I'm Robert Mullins. I'm also from the Computer Lab. My research is in the area of many core processors, but I was also one of the co-founders of Raspberry Pi, and more recently, one of the people who's started a low-risk project to create a completely open source SoC. Thanks very much. Looking forward to hearing all about the projects.
Hey everybody, I'm Tim, I'm from Major League Hacking. Hands up if the Wi-Fi is working. Yay! Great. So, yeah, you know I am. I'm here to help around hackathons all over the world, and that's pretty much what we do.
Okay, cool. The first team to present will be Magic IoT. Okay, yeah, and they're just about to present their hack. Christian. We are just having some technical difficulties. Sorry, like, this is probably the first time we've noticed them during the entire event, but yeah, they're annoying. Thank you for your patience.
Hello. We're honoured to be here at HackCambridge. So what we created was a product to bring the magic back to the Internet of Things. The biggest problem with the Internet of Things that I found, I bought some Wi-Fi light bulbs, and you have to get this app out. You have to like choose the colour, change it, switch on and off the bulb. It's a lot of effort. It's much better to just literally walk up to the light switch and turn the light switch off. So you end up just using these expensive light bulbs as normal light bulbs, which is totally pointless and a bit sad. So, how to make us happy again? Well, implement gesture technology to control your Internet of Things devices. Evgeny here will demonstrate pointing at the light bulb, gripping it, and then changing the colour of the light bulb by just movements. Unfortunately, because we haven't got our own Wi-Fi network, we can't change the colour, but if you look at that square up there, that's the visualization of the light bulb. With like 2 or 3 lines of code, it would be the real light bulb. If there was Wi-Fi. The next thing he can do is say I'm sitting on my couch and I want to change the music on my speakers. He'll point at the speakers, which is the microphone stand, and then he can change the volume. You can only see in the top corner because there's no music, because there's no Wi-Fi. But once again, we're interacting with Internet of Things devices, and you can do both of these at the same time. So yeah, both at the same time, go. So you can be changing the volume, changing the lights, it's basically a party. And also, I'm about to demonstrate, we can both be standing there and we can both be interacting with different devices at the same time. So we can support up to 6 people, each holding 2 devices, so that's 12 devices in total, in a big room. So I'm changing the light bulbs, and he's changing the speakers. Yes, that's the functionality. The web. Need to make it. Oh, we found a glitch. It'll be because I left the screen, whereas I've never left the screen before. So it's not actually rejecting the changes. So we haven't released the grip. But yeah, it's quite funny. So the way this works, we draw a vector. So the Connect SDK gives us the coordinates of all the joints on the body. We draw a line from the elbow through the wrist and project it forwards. We also know the coordinates of our Internet of Things devices in the room. So we get these, we draw a sphere around these devices, and we see if the line intersects with that sphere via some vector calculus. Also, if you're further away from the device, the sphere will be bigger. Give a round of applause! Oh. Are there any questions?
Or maybe not. So obviously you need a camera for that. So if you're in your home, how much of the house can be covered by cameras? You have to go walk to some particular place in the house to control your devices, or would it be easier to wire up a house so that this happens in every room, in every place in every room?
So the range of the Kinect sensor is actually quite large, so you can put it in the corner of a big room and you'll be able to do almost your entire living room. You don't need to be facing the camera either to control the devices. It just needs to be able to see your limbs to work out skeleton. You could reduce the cost massively by going to a much more basic camera-based system, but the Kinect was there and we wanted to use it. The Kinect itself cost me about £40, and then you just need a normal laptop running Windows to control it, so it's not overly expensive. And given you're paying sort of £50 for a light bulb, the ability to control them is probably more important. Anyone else?
Thanks.
We've got one.
So, like, the wireframe thing is that pretty easy to do with the Connect API? or did you have to do a lot to make that happen?
Yes, so the wireframe actually comes from one of the sort of example projects from Connect. It's just to demonstrate that it can track coordinates. Basically, it looks through each of the coordinates that get returned from the camera and plots them on the screen. We actually then just take those coordinates and do 3D vector calculus in order to make cool stuff happen. Once we've gripped an object, we change the vector plane, so we're actually always interacting with a side-to-side movement based on where you started gripping, rather than forcing it to be sort of an XY facing the camera movement. She'll always be, it's a more natural way of interacting. Time. Cool. Thank you.
Okay, thank you very much, Magic IT, and now Metabolize are going to set up. And could the next team just please come up onto the stage and wait in the wings? Thank you. So my memory's been really bad. City and around.
While this team's setting up, I have some fun credit card jokes for everyone. So, an American Express walks into a bar in Moscow, and the bartender looks at them and says, "Sorry mate, need a visa to get in here." Ba-doom-tsh.
Cool. So give a big round of applause to Moran and City for Metabolize.
Afternoon, guys. It's my pleasure to welcome you to the next generation of health tracking, Metabolize. So if you look at the health app market nowadays, you've got all these wearables. But the question is, are we using them right? So it's segmented really into apps that track your calories going into your body, like MyFitnessPal, and then you've got apps which track your calories going out, like Fitbit. But this is where Metabolize comes in. We combine the two, and we take out all the hassle of the user where they're trying to combine them themselves.
So what exactly we're trying to improve is that, so if you look at, here we have got some screenshots for the app MyFitnessPal, which is one of the most popular fitness app out there. So for example, let's say we had a salad. If you put that in MyFitnessPal, you'll get a list of all kinds of salads. You get salad dressing and all kinds of stuff. And further, if you just click on one of those, MyFitnessPal will keep asking you how much exactly did you take? Did you take 1 millimeter of salad or 700 millimeters of salad? So that just doesn't make sense for average user. So our goal is to make this experience much better for the user. So let's show some demo.
So as soon as the user enters the app, you get this screen, you enter all your metrics in, and most importantly, you say when your day actually starts, what time you wake up in the morning. Then, whenever you go into the app, it calculates how long you've been awake, and using your basal metabolic rate, it will, at that point, tell you how many calories you've actually burned since you've woken up, and then it will add in all the calories from the meals you enter. So it's a very, very simple interface. All it's doing is just telling you the deficit and surplus of the calories, which is what users are actually interested in. They're not really actually interested in all the protein and carb and fat grams. They just want to know, are they on track or not? So it's very easy to see your calories burned, but it's also very simple to add calories in meals.
So for example, let's say you just had some pizza, right? So you type in pizza, and as you type in, we make a real-time prediction on the side. So here you can see 210 calories. And you might also have noticed that the unit switched from serving to slice, which is the most relevant unit for a pizza. So now this works for many other examples like soup. We'll directly jump to cup. It gives you another estimation. Now, So I think we're out of time, but like just one of our favorite example, deep fried Mars bar. All right.
Hi, thank you very much. So there, you're saying that you give an approximation of roughly. So if I put in salad, like you did for MyFitnessPal, what would you do?
Sorry, could you repeat the question, please?
If you put in salad, would you give me a choice of which salads, or would you just? Why is it different from MyFitnessPal?
So basically, in MyFitnessPal, you put in salad, and MyFitnessPal go to make some query on a static database. Now, our app doesn't have any database at all. In the backend, we have one model that takes the user input. So if the user say salad, then we will just make a prediction on average salad. So, and then the user can further specify like tuna salad or other kind of salad. And as they refine their query, we'll also refine our estimation. So this is really all dynamic. So it works for all kinds of different dish names. So, right. So you can even work for dish names that the model has never seen in the data set. So the deep fried Mars bar doesn't exist in our data set. But we might still manage to pick up some information from deep fries and Mars bars and try to make some prediction from that. Yeah.
So that seems like the technically interesting part of this hack. Can you elaborate a bit more about the kind of technical implementation of that?
Sorry, I didn't quite get that.
Sure, sorry, I've got a very hoarse voice and I talk fast. So this seems like the core technical thing really this hack was about. Can you elaborate a bit more about kind of what's going on behind the scenes, like machine learning or whatever's going on?
Yeah, exactly. So what is going on is that in the backend we have two models. So we learned both models from tens of thousands of recipes with different nutritional labels. So from that we derive two models. One predicts the units. So we take the dish name and try to predict what's the most probable unit for that. And then we also
Thank you very much to Metabolize. And now next we've got Unchained setting up, and could Docu Flow please come up on the left? Thank you.
So while this team's getting set up, the new hackers, raise your hands. New hackers in the audience, awesome. Let's give these guys another huge round of applause. Of those new hackers, who would come to a hackathon again? Excellent. Who's going to Stir Hack next weekend? It's Valentine's Day, spending a hacker. Oh, at least one? One dedicated hacker? Oh, you're all too romantic. Look at you, soppy long. Cool, things go back really good.
Okay, just a round of applause for Melinda Navi from Unchained.
Hi everyone, thank you so much for having us. We sincerely believe that every person in the world, whether from the US, UK, or anywhere in the world, a citizen or a journalist, you deserve the right to speak freely. But the problem is, now in the 21st century, there are so many people that are suffering because of repressive governments. And we have the technology to stop that. And we have found a way, using blockchain, the technology behind Bitcoin, to repurpose it to send anonymous messages between dissidents and activists to communicate confidentially between each other. So the three benefits, obviously, of repurposing Bitcoin, obviously anonymity is a huge part of it. Decentralization, no government, no business can interfere with it. And lastly, because of the fact that it's decentralized, we also have the ability to make sure it's of public record. So once information's out there, it can't be tampered with. So obviously there's huge challenges with repurposing it. Eventually we found out that it's 40 bytes per second, but we found a way to eventually create a server and API that will make this work. So you're going to hear from Balan how we made it happen.
So the key part of our system is this relatively easy to set up little server that provides an API that enables enables the communication between an easy to use, maybe somewhat Twitter-like web application, something that you have seen before, and the incredibly complex nature of the blockchain. So this is a little bit more technical view on how this works.
So ultimately, it serves as a bridge between the more complex blockchain tools and the more simple web API they have in mind. Do you want to run an API query if you want to, or some brief demo? Okay.
So we have this.
Is the brightness up?
So, our very basic call of this API is the authenticate call, which basically tells if someone has permission to use the server. If I remember, no. So here's a user account I set up on the system. So now we have a token which can be used to not only request
So yeah, digging more into the tech, can you elaborate a bit more on, besides, I guess, using Python there, like from blockchain import star, what kind of stuff did you add on top to specifically kind of achieve your hack?
So your question is how did we...
Yeah, I guess what existing tools did you use and build upon?
So basically we have a Python-based application over the standard Bitcoin core node and node and wallet. And this application scrapes the entire blockchain, which is actually a really long time, but only has to be done once. Only has to be done for the entire blockchain when you set up the server. So this scrapes the entire blockchain for these kind of messages, and then of course then facilitates further communication, crafts the special Bitcoin transactions that become these messages eventually.
So I know you can't demo it, but can you explain what the user journey would be? So you've got a user that wants to use this, what exactly would they do and what's the end result?
Absolutely. So we showed most of the bulk of the technology of the app, but ultimately this can be used snuck in a flash drive. You can put it in the web app like we try to show in the mock-up. It's more about the technology. We're trying to find a bridge between the more complicated server and this service. For example, here you could have a username and password, and that can connect to your address that you're sending to or your private key. We just want to make it simple, almost a Twitter-like service, because there isn't that much amount of information you can pass on. You can send key text messages to core people through this service by putting it within the 40 byte limit of Bitcoin.
Thank you very much. That was a great presentation by Unchained, and now we've got Docu Flow setting up, and could Mitro please come up onto the stage? Okay, so now everybody, give me a cheer if you like the food here. And now shout out what you might want next time. Wi-Fi isn't the food, but yeah, we'll bear that in mind. We're aware of the Wi-Fi issues, and yeah, thank you so much for your patience again. Who here enjoyed working with Thales? Awesome. And just now give a big round of applause to Docu Flow.
Hold on for a sec, we're just setting it up. Okay, great, sweet. So, hi everybody. We are Feynman, Jordan, Naomi, and Mikkel. and we built Docu Flow. We started this hack when a friend of ours sent us his personal statement for review, and we read it, we sent him a bunch of thoughts, but there are many things that we were missing, and that's things that you think but you can't really express. So that's why we built Docu Flow. It's a document viewer that reads your mind. And the way it does that is by doing three things. The first thing is eye tracking. So we have, through an external API called XLab, we can track the pupils of Naomi while she's looking at the text, and we know exactly which parts she's focusing on. So what are you really reading? You're not reading the whole document, you're reading certain parts of it. Second thing we do is we read the gamma brainwaves with the Muse headband that she's wearing right now. The gamma brainwaves mean how focused you are when reading. You're not focused all the time. There are certain parts that maybe you're struggling or maybe they're very interesting. So we record all of that. So once we have these two sources of data, we're able to generate a report. And what this report actually does is it creates a heat map. And it's a heat map of focus on each line of the document. As I said before, the certain parts, being very focused on one part or another can mean different things. For instance, if you're working with code, maybe it means that you were struggling with that line to understand it. So maybe we can try. What you see on the way up there is the focus. And right now, the heat map is color-coded. Green means that you are very focused on that part. Red means that you're not really focused at all. And we also have a yellow-green color code, which means that it's so-and-so. Fabian can talk a little more about the tech behind it.
So in terms of technology, all the data starts with the actual headband. The headband communicates via OSC into a WebSocket server. That WebSocket server dumps all of our data into a Flask backend. The Flask backend sends the data over WebSockets to this front end, where the data is joined with pupil tracking data. This lets us know where someone is concentrating and how much they're paying attention to that segment of text. This data is then sent back to the backend for report generation, and we're able to see how much people concentrate on what parts of a specific document.
So there are multiple applications, as we said, not only reviewing text documents, but any sort of document, especially code. We found it very interesting. Imagine if you could do a pull request and tag certain lines where you struggle, or when other people look at your code, people can pay extra care for that. It could also work for any sort of document. Imagine reading papers and sort of evaluating how hard they are to understand, or which parts are the most interesting ones to read. So this is pretty much what Docu Flow is. It basically reads your mind while you read the text. Thank you.
So when you're looking at the report afterwards, is there any way to see like what the, like how do you see both of these like dimensions when you're reviewing the report?
Can you repeat again?
How do you view both of the dimensions? So you're doing the eye tracking, which is like what sections you're looking at, and also like the focus level.
So the data we collect is the average attention, or the average gamma wave level someone's expressing when their eyes are focused on a particular line of text. So the highlighting of the text is actually an average of, over the course of review, how much concentration did they spend on that piece of text.
Can you explain what the graph at the top is?
Yeah, so the graph is actually displaying the concentration at this current moment. Concentration meaning how focused you are. It's an experimental measure that Muse has created, and as I said before, it's sort of based on gamma brainwaves, which are the ones that you use when you're focused on a single thing. It only becomes accurate after 1 minute of usage. So right now, we're already past a few minutes mark, so it's probably doing quite well.
Thank you very much, Docu Flow. Okay, so we've got Mitro setting up next, and then could Viral please come up onto the stage? Thank you. Okay, so we're going to try something fun. We're going to find out which location is the loudest. So could I please have a shout if you're from Cambridge? Yeah! Give me a shout if you're from London! Give me a shout if you're from the USA! Yeah! Give me a shout if you're from France! Yeah! Spain! Italy, China, Scotland, Wales, Manchester, Canada. Brazil. Fantastic.
Last but not least, give a shout out if you're from the UK. Woo!
Okay, so while they're waiting to set up, we're gonna do the yet again more people are losing things game. Someone lent someone a iPod USB charger to charge the Project Tango tablet. If that was you, I now have your charger. Please come see me. We also still have a hoodie that hasn't been claimed, and I think that's it now. Everyone collects everything. Sweet. Oh, we got the display cable. Wonderful. So we shouted out quite a few countries. There's obviously some we've missed, some cities, some countries we've missed. If you're from somewhere and you want to show your pride, give us a shout on 5, 4, 3, 2, 1. Give a round of applause for Yorkshire!
Okay, so yeah, just give it a big round of applause for Mitro!
So our hack today, we incorporated a device called Myo. Now Myo is a device which recognizes specific hand gestures. And we use this to create a controller for a game. For example, here we have the Space Invaders. Now if I clench my fist on the green one, I will start shooting bullets. And then if I let go, it will stop. And then if I swing my arms, it will be able to move. Now this just engages the user in the game, which we like, which is why we decided to hack with Myo, essentially.
So a little bit more on the technical details of this hack. The Myo uses electromyography sensors to measure the electrical activity of skeletal muscles in your forearm, and therefore can measure the activity of muscles reaching all the way down into your fingers. So it's designed to measure 5 specific gestures at the moment. The first of which is an unlock gesture, so that's just tapping your thumb and middle finger together. The next one is spread fingers out wide. That's normally used as a play or pause in media applications. Then you have flicking your hands left and right, or in and out, because you can wear it on either hand. That's skip or go back a track if you're in playing music. Or the last one is you can grab and you can turn for a volume control to adjust volume. So we haven't exactly used it like that. As you can see, we've used it for playing Invaders. The Myo also incorporates 6-axis accelerometer and gyro, so that you get, as well as this great gesture control, you also get fluid motion control as well. And this particular game is a great example of that, because we're using the gesture and you get the nice smooth motion out of it.
The idea behind this is basically to try and control video games with hand gestures. We were originally going to start with, let's say, first-person games, where we realized how that could be a bit more complex. So we started with retro games. Something like this is very simple for us, and we would be able to animate these simple gestures. The Myo itself is not that good as accurate, specific points, locations. So if we're grabbing
I'll give you a chance to finish your speech. What are the limitations that you've seen with this technology?
Oh, yeah, I was... Sorry. Yeah, oh yeah, sorry. The script relatively knows where you are, but not specific points, so we can't do specific actions. Say, typing on a keyboard would be more difficult, but we can do actions like side swipes, and we can bind those actions to different events.
Cool. So specifically, the work technically you did was taking the existing API for this input device and then wiring it into an existing game.
Sorry.
Oh, sorry. Did you make the Space Invaders game?
The game itself we actually took apart from a template we found online. This is all in WebGL. We took a template and we basically just took it apart and we added our own code. We basically recoded the entire thing, added the connection to the Mayo, added a 2-player so we can see how we can, well, 2-player can interact with Mayo seamlessly. And yeah, basically. Yeah.
Cool, thanks.
That was more or less my questions.
Yeah, thank you, Mitro. We've got Viral setting up. Can Smart Jar please come up on the stage? Jordan's also going to give a bit of an announcement about the People's Choice Award and explain how that's going to work. Over to Jordan.
Okay, so People's Choice Award, which hack was most popular at HackCambridge? In order to vote for this, go to hackcambridge.devpost.com and go to submissions, find the projects that you like, and just give them a like. You'll see a huge grid of projects, and if you click into one of them, there will be a like button on the page that follows. Right now, we'd please like for the people in the first 4 rows of the balcony and the mezzanine and the floor to do so, because if we try to do everybody at the same time, the Wi-Fi is going to go down and these presenters are not going to be happy.
Okay, hello everyone. I'm Petter for Team Viral, and what we try to do is model the spreading of epidemics in a modern society. Now you might ask yourselves, why is something like this important? Well, one of the key conclusions that we can draw from a model like this is, for example, in the critical case, what percentage of the population will end up getting infected? And this is actually crucial if you're a government in a pandemic situation. For example, the government of my country grossly overestimated the amount of vaccines that was going to be needed for the recent swine flu pandemic. They ended up ordering a couple million of them, and they needed less than was needed for the actual seasonal flu. So something like that is actually a really important modeling tool. And the approach we've assumed for this is to use a modern approach of multiplex networks, which essentially tries to model 2 separate layers of interactions and then combining them together. So you can connect people in the physical layer, where those are people you actually come in contact with, and along those links, the disease is actually allowed to spread. And you also have an information layer where people are connected through the connections on Facebook, Twitter, and so on, and also repeating some of the edges in the physical layer. And along those edges, someone who's aware of the epidemic can tell you if you're unaware of the epidemic. And when you're aware of the epidemic, you can take precautions to reduce the probability of getting infected. For example, you may decide to stay in the house. You may decide to get vaccinated. You may decide to wear protective masks or something like that. Now, researchers so far have mostly done this by generating random networks and just simulating some kind of Markov processes on them. What we wanted in these 24 hours is to build something that could actually come close to a real-world simulation without actually releasing a dangerous virus involved. So the main idea is essentially we built an Android app, the interface for which you can see here, which is extremely simple. So each user is modeled by their Android phone, and it's a very simple interface. They can be either susceptible, they can be vaccinated, or they can be infected at any point in time. And we model awareness by having a secret code appear for a small fraction of the nodes. And if you type this code in and you're susceptible, you become vaccinated, and your probability of infection is much less. And this code is actually bound to a single session, so you can then share it on Facebook or Twitter to other people who can punch it in and become aware. So we're implicitly simulating this information layer, which is so that the app contains minimal state. The app just sends GPS data to a central server where we crunch all the data, calculate the mutual proximities between the nodes, and using that we calculate the probability whether or not some edge is going to be used for disease spreading. We also log all of this data so that the researchers can use it for their publications, and we went a step further than that. We made a C++ code which takes this data, the latest logs, and gives a nice zigzag diagram which represents the whole thing. And the researcher can just take this code, shove it into their paper, and they have a publication ready. So yeah, thank you.
How many people do you need to get a realistic simulation of a virus in the population using your Android app?
Well, I mean, ideally, a researcher could set up some kind of an experiment where a group of people would be maybe locked together in a room or in a relatively small space, preferably open space because GPS is easier to use when you're not in a building. But
Also more precise.
yeah, also more precise. So we're expecting to be able to accurately predict like human psychology and human metrics if there's a group of people. Some of them might know each other, some of them might not. But let's say about, I don't know, a couple of dozen people at least would be enough to get already some sort of useful metrics of the dynamics of the processes. But of course, the more the better.
So you think that's enough to get real data about a virus in the population?
Well, we have a model here which started out with 12 nodes, and we have had parameters, of course the parameters can be very easily tuned. And in this case, the parameters ended up simulating kind of a catastrophic pandemic scenario. In the end, if you didn't get vaccinated, you got infected. But it really depends on the initial parameters. And those are very easily tweakable, so you can rerun the experiment multiple times.
So we're just going to have Smart Jar set up, and could Deadlock Empire please come onto the stage? Yeah, so I'm just about to make a very shocking announcement. There's been a bit of a plot twist. We do not have 7 teams presenting. We've got 8. So yeah, so just keep your hearts beating still. It's all good, it's all under control, but yeah, we'll have 8 teams presenting now. So just that little announcement there. Thank you.
Just a reminder, folks, that if you want more free stuff, if the free drawstring bags worth of free stuff wasn't enough for you, if all of the wonderful sponsor t-shirts weren't quite enough for you, we still have an actual pile of free things down here for you to claim. So at the end, come grab them, please take them all home. And over to Smart Jar. Give a round of applause.
Good afternoon, guys. My name is Imran, and this is my team. This is Smart Jar. We hope this is a small step forward towards an IoT-enabled household. And the way we're doing this is by tracking the consumption rate of food for all replenishables, like coffee, like sugar. We hope to predict when we're going to run out of food, let's say run out of coffee, and then order in the food via supermarket APIs before you actually run out. And the idea is in the future to provide health analytics on our consumption and also to provide some sorts of spending analytics depending on certain use conditions.
So this is a flow. So in our project, we started all the way from the hardware where we hacked a weighing scale. We have a hub where we can connect multiple of these scales and send the data to our server. And we also have a front end for the user so they can track their data and their usage. So we began all the way from Dome Kitchen weighing scale, and we managed to hack it and connect it to the internet and to the cloud. And this will measure the replenishable that you put on top of it, which you might have in your fridge, and it will basically derive the consumption rate.
The hub acts as a bridge for all the different BLE devices, so it scans for all of them, and then it allows you to use a barcode scanner. It's on the app, but I can't really show it here. On the barcode scanner to actually, if you scan a barcode, you will link with the Tesco API, bring all the product data in, and send that all to the server.
For the server side, we decided to host our app in the Google App Engine, harnessing the Google technologies. And so basically, we're using the NoSQL database for our data store. And Annie is going to explain the stuff in the back end.
So just to give you guys a quick idea, so this is a very simple web interface that we've put together just for demonstration purposes. So a user can come in and can write down their app ID, their hub ID, which will eventually be implemented into a full login flow using Google. And then you get these graphs here that track your consumption, and these are dynamic graphs that update over time using an AJAX asynchronous request. So sort of big talking points on the back end is the linear regression algorithm that we're using to keep track of consumption rate and to ensure that when the user is going to run out of a product, that we can predict it's going to happen and we can place an order for this product before they actually run out. We are very much into the idea of customizability, so the user can specify which products they want to have at low cost, so they can group orders together, or products like milk, which you want as you don't want to run out of, so you can get delivered to you as soon as possible. So just a quick note on the future. We want to have smaller devices and we want to integrate this on a very large scale. Thank you very much.
Can you say a bit more about you hacking the scale and how you connected it?
So essentially, we got a pretty standard weighing scale, as cheap as possible from Amazon, and we thought it would be quite fun to see how we could interface with it and connect it an Arduino and see how we can actually send data from here all the way up into the cloud and have a really cool application. So it was fun, it was difficult, we had to go through a lot of stuff, get some instrumental amplifiers which are really difficult to find, but we managed to set up our own circuit and we calibrated it correctly and it ended up working great at the end.
So does the weight actually talk to the cloud, or does it go through a computer?
Yes, so the Arduino will communicate with a BLE device, which is a Bluetooth Low Energy device, and the BLE device through the phone will aggregate all the data from various scales and send that up to the server.
Cool.
Thank you very much.
Thank you very much, SmartJar. We're just going to have Deadlock Empire set up, and in the meantime, Jordan will just give you guys another announcement about DevPost.
Hi guys, so at this point the entire venue should be open to doing the People's Choice Award. Once again, the instructions are go to hackcambridge.devpost.com, go to submissions, you'll see a grid of submissions, go find the ones that you like, click through them, and you'll be brought to a page where there's a like button, and just hit that like button and you will give them a point.
Big round of applause for Deadlock Empire and good luck.
Concurrency programming in a parallel environment is hard and prone to mistakes. Some of these mistakes or bugs can be really harmful to the security of applications. That's part of why we created this application, the game, the Deadlock Empire. In this game, the player assumes the role of the computer scheduler. In each level, there is a program that consists of 2 or more threads. The player moves or steps through and provides and performs context switches in order to break the program. In this example, for example, the only way to break this program is to have both threads enter the critical section at the same time. To do this, notice that the instruction A equals A plus 1 is not atomic and can be separated into value read and value write. If you do these operations in the right order, as my colleague is just doing, you will encounter a state where both threads enter the critical section. Thus, you win the level because you broke the program and proved that it's not thread safe. We have implemented 16 levels during this hackathon. They progress in difficulty and we keep adding more synchronization primitives as we progress. For example, we added the deadlock. The deadlock is an alternative win condition. If you succeed in making the threads arrive at the deadlock, if you block all of them, you also win the game. In this situation, notice that the thread on the left has first lock and then a second lock, while in the second thread they are reversed. Thus, this forms a simple deadlock. Well, simple for some. This is still a rather difficult area of computing, so this is why we think this game would be quite useful. As the game progresses, in the end, we find the story levels. You will find these 3 called in the section Deadlock Empire. These levels contain also story to provide the player with more fun, because it's not just an edu game, but the player still beats the game by breaking the game. In this scenario specifically, the player battles a two-headed dragon mounted by a sorcerer, and the way he beats this level is that he makes the heads battle against themselves by exploiting their critical section. This is too difficult for my colleague to succeed on the stage, sorry, but it's one of the final levels. In the future, we would like to add more features to this, for example, lesser memory models and the possibility to account for compiler optimizations. Thank you.
So how are you detecting that it's entered a critical area and having an error? Are you just choosing, like, you know these sections cause the deadlock, or are you actually simulating it?
The way we detect the case where you enter a critical area twice is that basically we have an internal, very simple language which has a primitive instruction called a critical section, and every single time you step through either of the threads, we do several kinds of checks to make sure that the program is still in a consistent state, and if we detect that that is no longer the case, we declare victory.
So could you use this for real code, to find problems with real code and gamify it? Or is it just for the test code that you've created here?
Our examples are unfortunately kind of read-only. It does not allow you to enter arbitrary code, which would be a very nice feature.
What would it take to get what you have now into that?
We believe it can be done, and we did not do an approximation between the two of us, but I think it should be doable on the order of weeks.
Thanks.
Is there a way for other people to add more examples?
Yes. We didn't mention yet. All of this is open source. It is on GitHub. We already have a web page. It's deadlockempire.github.io. You can feel free to send us pull requests, and we will accept them under conditions of uncertainty and very little time for code review, I guess.
A big round of applause for everyone who presented. Cool. And now Chris is going to come up and just start announcing prizes, and we're going to do that process. So, yeah, over to Christian. Jordan.
Before that, would Paula Schwartz from the World Economic Forum come down to the stage, please?
Okay, hello everybody. It's been quite an event. First things first, with the sponsor prizes, the API prizes, we're going to go through them in order. I'd just like to ask, when I announce it, that a representative of the company will come forward on the left side of the auditorium, and we'll wait. We're aware that you're all upstairs, so we'll wait for you to come down. Just try and be swift with you when you come down. So this event was pretty amazing. We all learned a lot, and we all made some amazing things. And I just want to go through a few thank yous that, well, we need to go through. So firstly, an interruption.
Sorry, yeah, another plot twist. Woo! Could the judges please come backstage left to discuss the judging? Sorry about that. Over to Christian again. Thank you.
Okay, while we're waiting for that, just a quick note about our travel reimbursements. There's an email that's went out to you, and this could take a few weeks for us to process. We're going to wait until the end of next week before we start looking at them to give you time to put them in. If you haven't had a link emailed to you about travel reimbursements, just flick us an email or ping us on Slack, and it could just take us a while, so be aware it might take us a few weeks to get the money out to you. Okay, right, so it's been an amazing event, so let's have, firstly, I don't know how we would have done this without them. Let's have a big round of applause for Major League Hacking and all the work that they've done here. Equally, we've got this amazing venue, the Corn Exchange, provided to us by Cambridge Live, who have graciously led a group of students who are probably not fit to be in a venue of this size, to be in a venue of this size. So thank you, Cambridge Live, for hosting us and giving us an amazing venue. Thank you. And an event like this just isn't possible without just the generosity of all of our sponsors. And well, the stuff that they've done is incredible, and not only how they've helped make the event happen, but all the mentors they've provided and the APIs they've given us access to, and the amazing prizes for using those APIs. So I would like to thank all of our Kilo sponsors: Costain, Jane Street, Tractable, Square, MailJet, Amazon, Google, Origami Energy, Softwire, Bank of America, Merrill Lynch, our mega sponsors: KCG, DE Shore & Co, Man AHL, Mendley, Morgan Stanley, Citrix, Capital One, Palantir and Skyscanner. Our giga sponsors: G Research, 2 Sigma, Bloomberg, HPE Haven On Demand, Improbable, Geospock, Metaswitch Networks, and McKinsey & Company. And our terror sponsors: Darktrace, Cantab Capital Partners, and GSA Capital. And finally, our incredible co-host who's done so much to make this event amazing, Thales. Can we give all of our sponsors a huge round of applause? Okay, next. Okay, so I've already briefly begun on this, but all of our amazing mentors from all the companies, they've given up so much of their time, so much of their knowledge, and to make your hacks amazing. Can we please have a huge round of applause for all the mentors that help you make your hacks happen? Next, those people in the orange t-shirts that just always seem to be there, always tending to things that are going wrong and helping things and making your life generally easy, providing food for you, taking you places. Our volunteers have been incredible. Thank you so much. And the food has been pretty good. Thank you, Padini, for doing all our catering. We love you. And last but certainly not least, all of you guys, the hackers, for coming all this way to Cambridge to hack for 24 hours, and well, especially for putting up with some dubious Wi-Fi issues. You really pulled through. We love you all. Thank you so much for coming, and thank you for making great things. All right, let's get to some prizes. Okay, so firstly, we have the best use of the HPE Haven On-Demand API. Now, I can't think of off the top of my head what this prize is, but it's pretty good. So, we have, the winner is, I don't know if I pronounced this right, Sato, S-A-A-T-O. So that is Josh Vandal, Woodsheisen, Alexei, these are really difficult names to pronounce. Sorry? Okay. For the prizes, they say come meet them at the booth afterwards. They're right here. Okay, they're right there. You guys can have some photos. We've got photo opportunities over here. Yo, come get a photo. Let's do it. Okay, so while they're taking some beautiful photos, let's go to the next API prize, the best use of the Mendeley API. Right, so the winner of the Mendeley API is Leith. So that is, I'm going to butcher all these names, Alexis Sazanovs, Chiju Wu, and Dilana Mincheva. Could you please come downstairs as well as Mendeley representative to receive your prize and have a lovely photo. Okay, so the next API prize is the best use of the Beaker API, for which we've got some nice 2 Sigma goodie bags. This one we've actually got the winner and a runner-up prize for these ones. So firstly, the winner of the best use of the Beaker API is Clusterpunk, a little exploratory research by Paul Scherer. Please have a 2 Sigma representative for photos, as well as Paul to claim the prize and get some photos. Okay, so the runner-up is for this prize is Authorify Machine Learning with Dictators and Taylor Swift. That is Natasha Lacheva and Alexei Morganov. Okay. Okay, so where's Mendley? Where is Leaf? Are they down here? Is Leaf here? If you're Leaf, can you put your hands up?
So Joyce from Mendeley has popped off home. But thank you, Joyce. We're going to take the photo with Christian.
Okay, who do we have down here? Beaker runner up. Okay, can we first? There's somebody else from 2 Sigma to take this photo. Here we go.
So sponsors, once we've announced your prize, you can hang around this area so we get the photo, that'd be great. Ready?
Okay, sorry about that. Okay, so the next one, unfortunately I don't have all your names for this one, but this is the best use of the MailJet API, so please have a MailJet representative and Feeder for winning the MailJet API prize. Okay, next. Okay, so next is the best use of the Nessie API. So could I please have a representative from them, as well as the winners of the team Microfinance. Okay, we'll have a bit of a break just to let everybody get down. How's everybody doing? Okay. I guess I'm tired too. What is our next API? All right, well, I think they're still around here, so I'll actually announce them now. Okay, so next API prize is the best use of Amazon Web Services, AWS. Another prize for these people, Authorify Machine Learning with Dictators and Taylor Swift. Can we please have them here again, and a representative from AWS. Yeah. Okay, so next we have the best domain from domains.com, and the winner of this is one Pandelis Sembajes with mlh.sexy. Can we please have you down? So next we have best use of the Google Cloud platform. And your prize, like you still come down, but your prize is a £1,000 Google voucher to continue developing your application. So that'll be emailed to you afterwards. So the winner of the best use of the Google Cloud platform is Rockslide. So can we please have the team members from Rockslide and a Google representative down here to take a photo? Okay, so the next API prize is the best hardware hack by ARM. And we don't have that yet. Is ARM in the house that can give us an answer on this one? They're very picky and very undecisive. But for a good reason, because there are a lot of amazing hardware hacks.
So while that is being discussed, I hope you've all had a fantastic time, met some really wonderful people. If you want to keep interacting with those wonderful people, there's actually a Facebook group for this community. If you go to Facebook and search Hackathon Hackers Europe, or Hackathon Hackers EU, you should hopefully find our group. We hit 3,000 members this week, and it's a group where people discuss tech and place where people discuss tech and hackathons, and they're all wonderful, friendly people. I recognise quite a few faces here. So please join that and come have a chat with us.
Definitely should do that. It's a cool place. Okay, so we've got an answer for hardware by ARM. So we've got some ARM representatives over here, and if we could please have Cake Mix for the best hardware hack at HackCambridge. Okay, so the last API prize is going to be Bloomberg's favorite hack and a few of the winners of the various Bloomberg challenges that they've been. And for that, we're going to have someone from Bloomberg introduce those. Do we have someone from Bloomberg to give the verdict on those?
Well done to everyone. We've really had a good time. Well done to everyone who took part in the programming challenge. We had 100 people take part, which was amazing. So we gave away all the donuts. 6 people have picked up their drones. The winners of the mini drones are in the Slack chat, so please check it because we still have your drones here. So the winners of our favorite hack prize were. Drumroll? No. Were Deadlock Empire. Thank you very much.
Okay, so that's all of our API prizes. Can we have one more round of applause for all these amazing hacks and our sponsors for donating the prizes? Okay, earlier we called for one Paula Schwartz from Startup Boat. Is she around? No, okay, so she's not. All right, we will continue on. Okay, so some of you will remember, well, all of you will remember and will continue to experience some Wi-Fi issues during our event. And it did still get better through a bit of troubleshooting, through cooperation with you guys, but I just want to single out a couple of people who really made a difference in this regard. So for about 6 hours straight yesterday, there was one hacker, some of our Wi-Fi engineers, and someone from 2 Sigma just working away at the Wi-Fi. And I just want to give a huge thank you to 2 Sigma for helping out, but especially a hacker for giving up, well, a good portion of this hackathon. Still managed to create an amazing product, by the way, to make it so our Wi-Fi experience was better. So we've got a little something for him, but can we have a big round of applause for Robin McCorkle? All right, okay, he's on his way Because next we will be going through the winner announcements, security challenge, best gaming hack, people's choice, and funniest hack. We'll be doing security in a little bit soon. Okay, do we have results? Do we have a verdict on all our prizes? Okay. Okay, all right. Okay, so Robin's almost here. We'll wait for him to get up because I've got something for him. I mean, this guy says he enjoys doing it. I don't understand. Networking confuses me. All right, one more round of applause for Robin, fixing your Wi-Fi. Okay, so next we're going to do the funniest hack, which for me, I found it was very hilarious towards the end of the event, and it gave me a good bit of relief towards the end. I think it gave all of you a good bit of relief as we're frantically typing away with Slack, and we get some casual responses, very, very intelligent responses from this hack. I don't think I need to give this any more description, as our funniest hack of HackCambridge is the Texty bot. If we could get the Texty bot down here for some photos and your prize. Okay, so now for what you've all been waiting for. Okay, so I'm having a bit of trouble reading these. It's okay. Can I have some help with this piece of paper? Okay, cool, we've got it. All right, so firstly, the third place hack. Amazing hack, I was pretty impressed with it. Okay, so firstly, for third place, we have Metabolize. Give a big round of applause for Metabolize. Our third place prize is a Kindle for each member of the team. Let's, where is Metabolize? Yeah, okay, come up. We've got some photo opportunities for you and some prizes. Tom, can you be in a photo? Okay, while they're doing that, we have our second place hack. Right, here we go. Our second place hack, winning, for each team member, a drone, a wireless keyboard, a little mini wireless keyboard, and a wireless mouse is SmartJar. Can we run applause for SmartJar? Okay, before we get to the People's Choice and the first place, we've got two very important hacks to announce. First, we have the gaming and VR hack by Improbable. Do we have someone from Improbable to announce this?
Adrian, where are you going? Come back, Adrian. Is it me?
All right. Let me just. Okay. Using our very fast Wi-Fi.
Cool. Cool. So this is the Roll Prize for the gaming VR category. So really, really good entries across the board. Specifically from our side, we're looking for kind of the underlying technical difficulty and kind of what was accomplished with the time. So yeah, in third place is Magic IoT. I wish I could tell you what was inside the bags which you've won, but you'll have to find out for yourself, because I don't know. But they are very fashionable. So, next up is Programmer Hero, which is a Guitar Hero clone written in Haskell using OpenGL. Pretty sick. This is what we like to hear in Probable, the union of crazy functional programming and crazy gaming.
So, just so you're all aware, this isn't the team that just won. It takes you a while to get down, so you're a bit out of sync. This is second place, so give them another huge round of applause. And finally, the first prize for the Gaming and VR category for us goes to the Deadlock Empire. Really fantastic hack, and probability of being #1 on Hack and Use in the next 48 hours is very high. Great work.
Okay, so our next prize is from our very amazing co-host sponsor. This is, I would like to introduce the grand prize for the security challenge by our co-host, Thales.
Great. Okay, hello everyone. So, I'm back, you saw me yesterday. And I must say that at Thales we've been super impressed by all of you. Okay, the fact that you've stayed 24 hours doing like really, really cool stuff. The drive you have shown is amazing. And you guys are the future, so we need you to keep that drive. Okay, you've been great. So give yourself a pat on the back, saying well done. But of course, oh yeah, a little clap. Anyway, but of course we're here to raise awareness of security. It's amazingly weird, but also not surprising, that only 4 teams entered for the security challenge. Especially because we're giving 200 quid to each person. But this shows, this actually proves our point, that people don't think about security. And as I told you yesterday, the encryption trends are skyrocketing. The more data we have, the more we have to think about security. So I'm here to tell you that every one of you please, everything that you create, now and in the future, think about security. And on that, I'm going to go on to the winners. So, the winners have shown amazing passion for what they've done, and that's why we absolutely love them. Okay, we loved all the other teams, but of course these guys had loads of passion, and they really focused on operation and ease of use. And this is something, as well, portability, that people don't associate with security. Now I'll give you one last clue. These guys really focused on identity management, and of course this is amazing stuff that we're focusing in the security world. So, without further ado, clear pass one. Countdown. 200 quitting and medals. And also, while we do that, a lot of you came to our stall to play our Secure World game. So I've got here the winners. I hope you're still here because you also get Amazon vouchers. So, Thomas Pullman, you were the first, you were the winner. Are you here? Thomas Pullman? Yeah, come downstairs. Woo! Excellent. Now, in second place, we have James Potecki. Are you here? James, yay! Excellent. Nice one, second place. And third place, we have Matt Dean. Matt Dean, are you in the building? No? He's not here? It's okay, we'll email him the voucher code. But thank you so much, guys, for taking part. Excellent. Thank you.
Okay, can we have one more round of applause for Thales, our co-host? Without this event, it would be impossible to have it. They've been so helpful and so amazing. One more round of applause for Thales. Okay, just a quick note about our Project Tango hacks from Google. Just really quickly, we could have our Google person coming up.
He's too shy, so I'm going to do it instead. So we had a team working with Project Tango, and Google were really, really impressed. So they want to let you know that you can actually keep Project Tango. So, well done.
Okay, so the next hack is our People's Choice Award. So this is the hack that you guys preferred. Right. Without further ado, our People's Choice hack is Docu Flow. Give us a bit of suspense before we announce the grand prize. Still, how's everyone doing? Still tired? Okay. Grand prize. Yeah, like some suspense. Okay, now, alright, so our grand prize for HackCambridge, the best hack of the bunch, is Deadlock Empire. You guys have all done such an amazing job here at HackCambridge. We love you all. Again, thank you to everybody involved, our sponsors, our volunteers, Cambridge Live, Major League Hacking, you guys, our judges. The list is pretty much endless. It has been a really, really good experience. I don't believe that anybody has anything else to say. Any notes? Okay, we've got something from Major League Hacking before we conclude.
So, as Major League Hacking, we work with a lot of student hackathons, and we know how hard it is to organise these events. So, I just want everyone to make a huge round of applause after 3 for the organisers who have worked really tirelessly to make the Wi-Fi work, to give you the food, to make sure any problems that arise were fixed the entire weekend. So after 3, make as much noise as you can. 3, 2, 1. There's more hackathons going on every weekend, so definitely check them out at moh.io. Last thing is, if you have hardware, please return them at the very front. That's it from me. Happy hacking. Thanks, everyone.
Thank you so much for coming. I hope you had a great time. And just give yourselves a big round of applause and hopefully see you all next year. If you have any hardware to return, please come down to the hardware lab by the stage. We know who you are if you haven't returned any yet, so please come return it and that'd be absolutely fantastic. Thank you, and thank you so much for attending.
Hello? Hey, everyone, the coaches are leaving from Con Exchange to London and Oxford at 6. Come back to the Con Exchange here at 6. Don't be late, if not, it might leave without you. And